Chapter 29 of Astronomy, the Science of Heavenly Bodies, by David Todd. Chapter 29, The Eclipses of the Moon. Of all the weird happenings of the nighttime sky, eclipses of the moon are the most impressive. Rarely is there a year without one. What is the cause? Simply the Earth getting in between sun and moon, and thereby shutting off the sunlight, which, at all other times, enables us to see the moon. As the Earth is a dark body, it must cast a black shadow on the side away from the sun, and it is the moon's passing into this shadow, or some part of it, that causes a lunar eclipse. Sun and Earth being so different in size, the Earth's shadow must stretch away from it into space, growing smaller and smaller until at length it comes to an end, the apex of a cone, 857,000 miles long. If we cut off this shadow at the moon's distance from the Earth, we find it about 6,000 miles in diameter at that point. And this accounts for the fact that the curvature on the side of the moon, when the eclipse is coming on and where it is dropping into the shadow, is always much less rapid than the curvature of the moon's own disk is. When an eclipse is approaching, the eastern limb will be duskily darkened for half an hour or more because the moon must first pass through the outer penumbra, or half shadow, which everywhere surrounds the true shadow itself. If the moon hits only the upper or lower part of the shadow, the eclipse will be only partial. And during the progress of the eclipse, it will seem as if the uneclipsed part had swung or twisted around in the sky, from the western limb of the moon to the eastern. But when the moon passes through the middle regions of the shadow, the eclipse is always total, and direct sunlight is wholly cut off from every part of the moon's face for a greater or less length of time, according to the part of the shadow through which it passes. When passing centrally through the shadow, the total eclipse will last about 2 hours, as the moon's diameter is about 1/3 of the breadth of the shadow, and the eclipse will be partial about 2 hours longer, an hour at beginning and an hour at the end, because the moon moves over her own breadth in about an hour. While the moon is wholly immersed in the shadow, her body is nevertheless visible as a dull tarnished copper disk, and this is caused by the reddish sunlight which grazes the Earth all around and is refracted or bent by our atmosphere into the shadow itself. If this belt or ring of terrestrial atmosphere happens to be everywhere filled with dense clouds, as was the case in 1886, even the familiar copper moon of a total lunar eclipse disappears completely in the black sky. Quite different from a solar eclipse, all the phases of a lunar eclipse are visible at the same time on the Earth whenever the moon is above the horizon. Eclipses of the moon are therefore seen with great frequency at any given place as compared with solar eclipses, which are restricted to relatively narrow areas of the Earth's surface. Nor are lunar eclipses of very much significance to the astronomer, mainly because of the slowness and indefiniteness of the phenomena. It is a good time to observe occultations of faint stars at the moon's edge or limb, and several such programs have been carried out by cooperation of observatories in widely separated regions of the world. The object being improvement in our knowledge of the distance of the moon, and in the accuracy of the mathematical tables of her motion. Search by photography for a possible satellite, or moon of the moon, has been made on several occasions, though without success. A lunar eclipse was first observed and photographed from an aeroplane, May 2, 1920. At the request of the writer, 2 aviators of the United States Navy ascended to a height of 15,000 feet above Rockaway, and secured many advantages accruing from a great elevation in viewing a celestial phenomenon of this character. End of section 29.